Hi guys, welcome to math class. Hope everybody's doing well. Today I'm starting on page 22, which is just a list of directions. There's nothing for you to do on page 22. However, before you start using your calculator for this unit, I want you to turn on your diagnostics. So I'm going to show you how to do that. Okay. So you want to go to your graphing calculator and you want to turn diagnostics on. And the quickest way to do that is to hit second and the number 0 because that brings you to the catalog. Diagnostics would be the letter D. So if you go to alpha and then you hit the letter D, which is x raised to the -1 power, or just scroll down, it's just as easy. And you're looking for it to say diagnostics on. And then you just hit enter and it brings diagnostics onto the screen, and you hit enter again and it says done, which means it did it. When it says it's done, it's actually done it. Okay, so the diagnostics are on, which is great. And now I'm going to do my linear regression. Okay, so we've actually been doing linear regression for a little while. We were using that in the beginning of the school year to verify that we calculated the correct slope. So we're doing the same thing here, except this is not necessarily a perfect line. This is a regression where we're doing the line of best fit. So the first thing you would do is enter your data into the calculator. So to do that, you would hit stat and enter. And then you type in your data, which I did just to save a little time. But obviously you have to type it in yourself. So pause the video, type it in, and then just restart the video when you're ready. Okay? All right, so you type into the L1 and the L2, and you could really use any of your lists. I just tend to stick with my L1 and my L2 because those are the defaults when I'm going to do the linear regression. So the window is basically what you want to see when you do a scatter plot. So I look at my X list, and my lowest number is 26 and my highest number is 45. So I'm still going to use 0, but you could just do a section that's like, say, 25 to 50. Okay, so I'm still going to go 0 to 50, but I'll change it and show you a couple ways, okay? Now, if I was counting from 0 to 50, I would totally count by 5s. Now, my Y's, the lowest is 49 and the highest is 72. So again, I'm going to do 0 and I'm going to go to 75. But once again, I'm going to show you what it would be like if I changed it. And I'm going to count by 5s as well. Okay, so that's setting up your window, which you use your domain, X's, your range, Y's. Okay, and scale is like, how do you count? Okay. So I'm going to click on my scatter plot. To do that, you hit second, y equals, which is stat plot. You want to turn it on, and you want to make sure that the lists that are written are the lists that your data is in, and then just hit the word graph. So you see how it's up there. I do have one data point that's really low down here, so I'm thinking I may have made a typo. So I'm going to go back to my list. Stat, enter. And yeah, see here I have a 5, which is not correct. So I'm going to fix that. And you can just type over that, and that should be 54. So now I'm going to hit graph, and you do see it. Okay, now this blue line, that's from something I did earlier. I'm just going to clear that out, and I'm going to hit graph again. Okay, so you see how it's kind of up there in the corner? You might not like that, so you could always go back and change your window. So say I started this at 25, and say that I started this at like 40. That will zoom into the picture a little bit for you, okay? But then you have to remember that that's what you entered. So, you know, it's up to you, okay? All right, so that's what the scatter plot looks like. Now the directions for A, say enter the data onto your list, create a scatter plot, size the window appropriately so that it takes up the majority of the screen. Compare this scatter plot to the one you created in the last lesson, and you can do that on your own. Okay. Use your calculator to find the equation of the line best fit. So I'm going to do that. And to do that, you would hit stat over once to calc, and you're going to linear regression, which is choice 4. And what I do where it says store regression equation is I send that to my y sub 1. So to do that, you hit vars, arrow over to y vars, hit enter and enter again, and then enter to calculate. And there we go. So it's telling me that the equation for my line best fit is y equals 1.16x plus 19 just 19 because they want nearest integer. Okay, now what's the r and the r squared? The r is the correlation coefficient. That tells you the strength of the relationship or the correlation, the strength of how closely they're related. And what we're looking for is something that's really close to 1 or really close to -1. The sign does not indicate the strength, it indicates the direction of the slope. So the strength of a 1 is the same as the strength of a -1. So the correlation coefficient I'm going to write down as 0.95. We would consider that strong. Close to 1, strong. Think of it as 95 cents, close to $1. Okay? All right, so they're asking you to compare that to the strength from the slope from lesson 6. And in lesson 6, you should have had a slope of 1.25 or 5/4. So that's obviously very close. All right, so I'm just going to write that in here for you. Okay, so y equals 1.16x plus 19, and this was 1.25, and they're very close, okay, which is good. Explain what the y-intercept in this model represents in terms of low and high temperatures that are being modeled. So now the y-intercept is the 19. So that's basically the predicted degrees of the high temperature when low is 0. It's the predicted high temp, which is 19, when low temp is 0. Your y-intercept is always when there's a 0, okay? How would you interpret the slope of this model in terms of how the low and high temperatures change with respect to each other? Okay, so the slope is positive, which means that they're both increasing, okay? So we would want to say that it's a 1.16 increase. If that was negative, you would say decrease, all right? So it's a 1.16 increase in high temp for every 1 increase in low. Okay? All right. Any questions so far? Zoom me or just send me a quick email. Just take a second, make sure you understand this, and we're going to go on to the next page. Okay? Now, our correlation coefficient, which you should have right over here, was 0.95, and that is strong. All right. So for the next question, generally fuel efficiency of a car changes with the weight of a car. So just, think about that. What do you think? The more a car weighs, do you think that it's more fuel efficient or less fuel efficient? Do you think these things are even related? Okay, just think about that for a second. I know you guys don't drive cars, but you've been in a car and you have a lot of common sense. You're all extremely bright people and you have your own thoughts, so think about it. Okay. All right, so I'm going to enter these. It's going to take me a little minute. So if you want to fast forward, you don't necessarily have to stay with me while I'm entering these. But, if you want to, you can. Hopefully I don't make any typos, so this goes pretty quick. You guys are all doing well. It's so much more fun to do this in person, but it is what it is. Can't change it. Hopefully the day you're watching this, there's rain and you're stuck inside anyway. See, look, I made a typo. Okay, so 24 and 18, then 30, then 28, then 21, which I typed as 2, which is totally wrong. 21. Okay. All right, so there's our data, so we're going to do this. Okay, so find the equation of the line best fit. Enter your data into your L sub 1 and your L sub 2. Stat, calc, linreg. Make sure those are the right lists. Store regression equation, vars, arrow over to y vars, function, y sub 1, enter, calculate. Okay, so notice now the slope is negative, therefore the r is negative, which is good. We want that, okay? Because they're supposed to match. If they don't match, something is wrong. All right, so I have my nearest 10th would be negative 8.1. Nearest 10th would be 68.1. And the weight of the cars is in thousands of pounds. Okay, so there's no car that's 68 pounds. It's 68,000 pounds. Okay? All right. List what the variables represent. All right, so I'm going to leave this screen for a second, and I'm going to write on this. Okay, so I have y equals negative 8.1x plus 68.1. X is the weight in cars, the weight of the car. And that's in thousands. And Y is the miles per gallon, which represents fuel efficiency. Okay? Create a graph of the scatter plot. So I'm going to use the calculator for that. All right, so I'm going to make my window here. So my lowest X value is 3.2, so I'm going to go with 0 because it's really close to 3 anyway. And my highest is 6.8, so I'm going to go up to 8. And I would totally do that by 1s or even 0.5. My lowest Y is 18. I'm actually going to use 0 again. And my highest Y is 48, so I'm going to do 50. And counting by 5s would be reasonable. So I'm going to hit graph, and there you go. Okay. If you want to do a little sketch on your paper, that's fine. But if not, it's okay to just look at it on your calculator. Would you consider the correlation between weight and mileage to be positive or negative? So it's going down. So what do you think that is? Yeah, you're right. Negative. So I'm going to say negative. And you could say that the slope is negative, or you could say really nicely as the weight of the car increases, the fuel efficiency decreases. And I kind of use this as a sentence starter every time. As the X increases, the Y blank. And your choices for the blank are increases, decreases, or stays the same. Okay, so correlation is how things are related. Which parameter of the linear model predicts whether the correlation is positive or negative? And that is 100% the slope. If the slope is positive, then it's increasing. If the slope is negative, then it's decreasing. And it's definitely the slope. So when it's positive, both variables increase together. When it's negative, the X increases, the Y decreases. And you could name those variables. Okay? All right, question D. So you're just going to plug in the 4,300, but remember that's in terms of thousands, so you're really using 4.3. Okay? So Y equals negative 8.1 times 4.3, and where did that go? Plus 68.1. And you can just use your calculator. Round to the nearest integer, so 33 miles per gallon. Okay, and that's just substitution. Be careful. One of the things I noticed on the last test was a lot of you entered the 16 as a positive 16, and it threw your answer, question 9D. A lot of you got that wrong because you typed incorrectly, so really be careful. And remember that a negative and a subtraction sign are not the same when you enter them in the calculator. Okay, if we wanted to purchase a car that got 40 miles to the gallon, what weight of car to the nearest 100 pounds should we purchase, solve algebraically? So we're saying that Y is 40. So negative 8.1x plus 68.1. All right, so if you subtract the 68.1 from both sides, that would give you negative 28.1 equals negative 8.1x. Divide both sides by negative 8.1, and that gives me 3.4691, yada, yada, yada. So that would be 3,500 pounds. Okay. Any questions? Great, you guys got this. Okay, so I'm glad that you have watched this. I hope that everything is well with you. I'm just going to make sure that I was only going to do these 2 pages before I shut you off. 22 to 24. And that's it, people. All right, so we're done. Have a great day. Miss ya.